All right. So we've got a piecewise function up here. It's been chopped into chunks, broken into pieces. So we want to try and write as much of this equation as we can. Stylus. We have 1, 2, 3 different pieces. Ooh, that was too similar. I'll switch that one to pink. 3 different pieces. And we're going to try and write expressions for each of these equations, or each of these segments. So I tend to just go left to right. It's the way things are kind of traditionally written in a piecewise function. If we go kind of chaos around, that's totally fine. Do it in whatever order works for you. We're just going to take it chunk by chunk. So let's just look at this purple piece right here. Ignoring these. What do we know about this purple piece? What is our y equal? 2. Our y equals 2. Like, if it was just that line, we would just have that f of x equals 2. That's what our y is. But only when we have some conditions on our x. What do we know about our x for this one? I'm going to say, I don't have an arrow on both ends. So I know x is going to be between 2 things. What is x going to be between? Yeah, -2 and -5. So you can go with our -5 and -2. Can it equal either one of those? No. We've got an open circle at -5. We've got an open circle at -2. So both of these are going to be not equals 2. If you want to put it, you can put the word if in here. I genuinely do not care if you put anything between. If you just put like a, making it really clear if things are close. You can even do like a, I don't know how to break them apart. Just, otherwise I'm concerned we might think it might be 2 minus 5. So, I just tend to put something in between them. You can do a colon, you can say if, you can say when. You can say measure. Okay. Just make sure we know that those are 2 and then -5 between x and 2. I'm going to jump down and do the pink one because it's very, very similar. And this one's all slanty and weird. So I'm going to jump down and do this guy. What do we know about this guy? What's our y going to equal? -1. So whenever we have a horizontal line, it's just a number, -1. What do we know about our x's on this one? They're definitely going to be greater than 1. Can they be equal to 1? No. Because again, we have that open circle. We also have this arrow on this side, so that's why we don't have x squished between stuff. Here, x was between these 2 pieces. Here I've got, it's bigger than 1, but there ain't nothing stopping it. X can be 10, 1,500,842,543.4. It's just got to be bigger than 1. So let's look at the green one in the middle. You haven't tried to write an equation for a line in a long, long, long time. What is the equation going to look like for this line? What is our slope on the green line? How is it changing? Up 1 over 1. So that means up 1 over 1, that's our slope here. Oops. So 1x, definitely. mx, so up 1 over 1, that's our slope. What's our y-intercept here? 0. So we could say plus 0, if it helps you, put it. If you go, I don't like that, don't put it. Plus 0 is the exact same thing as not saying anything. What do we know about our x's on this one? It's between again. We've got another between. X is stuck between -2 and 1. And both of those dots are closed in, so that's when we input our equal signs. I think this is literally the only time we don't give you any of the pieces. I just wanted us to practice doing it from blank. It's not something we ask you guys to do on a regular basis. For the most part, it's we give you equations, you draw equations kind of vibe, or we'll figure out like those X pieces. But it's really good practice. If we can do the whole thing, we can definitely do chunks. Okay. Questions on the first one? Because the second one, we have done this pattern before. Oh, snap, what? That's another one of these b squared minus 4ac things. And what do we get on number 2 down here when a is 5, b is 3, and c is 0? Yeah, we should just get 9. Because we'll substitute our 3 in for the b. 4 times a is 5, so 4 times 5 is 20, times c of 0, 20 times 0, which is 0. So we end up with 9 minus 0. That's 9. Okay? Questions on that one? Awesome sauce. Because we are going to work some more with our absolute value stuff today. So we're going to be in the notes packet on page 9. It's the bottom one. So down here. Okay. So we used our kind of transformation form, is what we call it, yesterday to play match them up and figure out our h and k for finding our vertex. So I'm going to put our little transformation form up here so that we have it. I know I have it small, but I just have it right next to my equation. You don't have to put it there. Again, if it helps you, great. If it does not help you, don't put it. But the important thing we need to know from here at this point is I need to know what's my h, and I need to know what's my k. We worked with these a bunch yesterday, so just take a breath and go slow and be careful. What is our h? Positive 4. What is our k? Positive 3. So that means our vertex is at the point, parentheses, 4, 3. That's going to be where we start. Whenever we're working with one of these transformation functions where we have an h and a k, that's going to be where we start. That is always going to be an important piece. No matter if we're dealing with absolute values, when we start getting into other weird things, hk is always going to be an important piece. So then from here, we're going to make a table. And if you want to draw one exactly like the ones above it, totally fine. If you want to just make like a T table, that's totally fine. You want to draw the full grid like you put a Google Doc in here, totally fine. But the same policy holds. We're going to pick some x values to find some y's. And just like yesterday, I'm going to start with my vertex in the middle. This is my starting point. I want to be where the people are. With 4, 3, right smack dab in the middle. I think there's only one function in the entire year where we will not put our vertex in the middle. One. I'll tell you when I get there. So, when in doubt, aim for the middle. We're going to need some numbers that are bigger than 4 and some numbers that are smaller than 4. Because with this being the center, I want to know what happens on either side. That's going to let me get a good version of the picture. So what are some numbers bigger than 4? 5, 6, 57, could do 8, could go 9, 10, 11, 12, etc. But my graph only goes up to 8. So I'm gonna try and not wind up off the graph. Then we also need some numbers smaller than 4. Maybe something like 3, or maybe even 2. They're smaller than 4. We can do whatever we want with it. Now when it comes time to find our y values, we are going to need to be careful. And I'm actually going to grab all my stuff and scooch it over because I did not leave myself any space to do any work. I'm going to scooch that over just a smidge. Because what we're going to do is we're going to substitute our x values into our whole expression here, and we're going to need to be careful when we're simplifying. So if I take my 2 and we put that into our absolute value of 2 minus 4 plus 3, we treat our absolute values like they're parentheses because they're related. So what is 2 minus 4? Negative 2. So the absolute value of negative 2, and then plus 3. What is the absolute value of negative 2? 2, positive 2. So this is 2 plus 3. What's our y? 5. So we may have to actually write some work down somewhere to get there at this point. I will show us shortcuts for graphing as we get them. But we can just do this with like a plug and chug situation. We just gotta try things out. As we work with these more and more, we're gonna start to notice patterns. And once we start to notice patterns, we can absolutely use them. But let's take a look at our next one. So we're gonna take our 3 minus 4 in an absolute value and then add 3. So again, we treat our absolute values as a set of parentheses because it works the same way. What is 3 minus 4? Negative 1. So we have negative 1 inside our absolute value, and we add 3. What is the absolute value of negative 1? Just 1. Plus 3. So when x is 3, what's our y? 4. Because with x of 3, we're substituting it in here, and we get an answer of 4. Creating some ratios so we can see. So then I've got 2 more to do. We're going to have our absolute value of 5 minus 4. And then plus 3. So again, we're going to do our absolute values first. What is 5 minus 4? 1. Plus 3. So we have the absolute value of 1, which is, what's the absolute value of 1? What's the absolute value of 1? How many steps away from 0 is 1? Just 1. The absolute value of positive 1 is positive 1. So this is the same thing as a 1 plus 3. It's really, really important with these absolute values. You simplify what's inside and then take our absolute value. So this one we get a 4 on. One more piece. We've got our absolute value of 6 minus 4 and then plus 3. So again, We work with our order of operations. We deal with our absolute value first. So I got to simplify what's inside. So 6 minus 4 is going to give us 2. So when we have the absolute value of 2, what's the absolute value of 2? 2. How many steps from 0? It's 2 steps. So anytime we ask you what's the absolute value of, it just means how many steps away from 0 is it. Doesn't matter if it is negative. Doesn't matter if it's positive. It's just how many steps. So when x is 6, what's our y value? Five. We now have all the points we need. And you can absolutely do these 4 equations every single time. Don't necessarily have to do all 4, but you absolutely can. You can do more, you can do fewer. But we're going to plot up these points. Oops. Whoa, that was way too far for your pen anyway. We've got our 2, 5 as our first point. I've got 3, 4, 4, 3, 5, 4, and 6, 5. So we've got our little V-shaped set of dots. It should always look like a V. If it does not look like a V, we did something wrong. We either don't have the vertex or we were not paying attention to our absolute values. Because our absolute value should look like this when we graph it. And there are arrows on either edge. It should look like this. All right, the next question, the very, very bottom of the page asks, how does this differ from the graph of the parent function? That would be the one that we put on page 8. The very, very first one we did. I'm going to sketch it up here just so you guys can see it, just because that's one that I can do by eye pretty easy. So yours, you should have in your paper on page 8, but I'm going to just put one up here. How is the one we graphed different from the very first one we graphed, which is this gray one I have up here? What is different about the purple graph and the gray graph? Yeah, our vertex is definitely different. How far to the right did my purple graph move? 4. It moved 4 spots to the right. We took up this vertex and we went 1, 2, 3, 4. Hush your face. Don't do that. Thank you. No. Thank you. We took our vertex 4 to the right. How many spaces up did it go? 3. 1, 2, 3 spaces up. It takes this vertex and shifts it around. That's going to be some of the jobs of our H and our K. We're going to talk about the jobs that A, H, and K have specifically on Monday and how we can use that for stuff, but it's trying to get us to start to spot that. The shape itself, our graph is almost identical except for the fact that it got picked up and moved right forward up 3. What do we notice about our table over here? What do we notice about the values of our y's? Just because the way we don't have to do near so much work. With our vertex in the middle, what do we notice about our y's? And if we don't notice this, that's okay. Why did I highlight them like that? And it's not just because I'm extra and like rainbows. I mean, I am extra and like rainbows, but that's not why I highlighted it like that. What do you notice about the two that I highlighted blue? they have that same value. 2, 5, and 5, and 6, 5. They have the same value. How about for the pink one? Same value. Because we know that our vertex is in the middle, these pieces are always going to be symmetrical. They're always going to match up. Absolute values always are going to have that line symmetry. So because they have line symmetry, these pieces are going to match. So if we are sure of this match situation, we don't necessarily have to fill in all the pieces. We need to make sure we have the right vertex, so we're going to make sure we want to do at least one on each side. But we don't have to necessarily do all 4. We can do this with 3, for sure. So let's see what that looks like if we look over here. We're going to have one more to do. So page 10, we have one more piece like this. And we're going to do all the things we need to try and graph it. We have just a little bit more work when it comes to our equation part, but other than that, it's the same process. So we're going to want to make a table, because that's the only thing we have at this point as a tool to work with. We're going to pick our x values to find our y values. And we need our starting place. We need to figure out where is our vertex. We want to get our point. Where is our vertex going to be? Yeah. Our h in here, remember, it always has that opposite sign. So our h is going to be that -3. Always has the opposite sign. And our k, added on the end, that -1. -1. So just because it's negative doesn't change what we do. That's still my vertex. That's still going to be in the middle of my table. We're going to have our -3, and -1. It's really, really important that we get that sign correct, or we're going to be all kinds of off on our graph. So make sure we look for that sign. When we're trying to find numbers that are smaller than and bigger than, I know sometimes on negative numbers we get a little stuck. We have a cheat code right here. -3. I need smaller numbers. Smaller numbers that way. So if I know I'm starting with -3, what are some numbers smaller than -3? That way. -4, -5, could go -6, -8, -10, -100. They're all smaller than -3, but if we stay pretty close to -3, then we have a lot less work to do. So we can do -4. We could do -5. And then I need some numbers bigger than -3. I could go -2, -1. I could grab 0, 1, 2. I could go up to the positives. But if I just go by ones this way, I want to go by the same amount this way. It's going to make our lives easier. So I'm going to also just take -2, -1. If we stay fairly close to that vertex, the points should all be on the graph. If we start going on little wanders, if our vertex is here, and we start pulling some guys over here, we may wind up off the graph in some way or the other. So keep them fairly close together. And then let's see what happens when we start looking at these calculations. Let's see what happens. So let me draw a little barrier for us, just because I know that I tend to wander, and this will keep me from making stuff too big. So we're going to have our 2 times our absolute value, and we're going to grab one of our x pieces. I'm going to grab that -5 plus 3 and then -1. So there's a little bit more stuff to do here. It doesn't change our order of operations. I'm still going to do with my absolute value first. So that means I need to simplify what's inside and take an absolute value so that then we can do our multiplication. Absolute value works like parentheses. So if we look through this, What is negative 5 minus 3? Yeah, so this is going to be 2 times the absolute value. Negative 5 plus 3 is a negative 2. And what's the absolute value of negative 2? Positive 2. So the absolute value of negative 2 is positive 2. So this is the exact same thing of saying 2 times 2 and then minus 1. What is 2 times 2? What's 2 times 2, y'all? It's not a trick question. Thank you. 4. 4 minus 1? 3. So we're going to work them through order of operations style. Absolute value, simplify that down, then we do our multiplication, then we do our addition. We're going to practice that again because I know they're weird. So we're going to take our 2 times the absolute value. This time I'm going to take my negative 4. And then plus 3 minus 1. I always draw my absolute values really tall just so that I can tell it's not a 1. If your 1s and your absolute values look too similar, you can always put serifs on your 1 with a little flag. Just be careful. Because again, then we approach this order of operations style. I need to simplify what's in my absolute value first. What is negative 4 plus 3? It's not 3. Negative 4 plus 3. I owe you $4 and I give you $3. How much do I owe you? I still owe you $1. So with negative numbers, when in doubt, think about it as money. Negative money means we owe. I owe somebody $4, I pay them $3, I still owe them $1. Or, tools. You can type in negative 4 plus 3 on here and it'll tell you negative 1 minus 1. So what's our absolute value of negative 1? What does this piece simplify down to be? Our absolute value of negative 1. How many steps away from 0 is negative 1? 1. So then we have 2 times 1. What's 2 times 1? 2. So we have 2 minus 1. What's 2 minus 1? 1. Okay. Questions on those two? I know there's more calculation for us to do, but just checking in. 2 more to go. Same kind of vibe. I'm going to have my 2 times our absolute value. This time I'm going to take my negative 2 plus 3 and then minus 1. And I'm working my order of operations again, working what's inside. What is negative 2 plus 3? $1. Yeah. So I owe you $2. Give you $3. You have a net positive of $1. So positive 1. Minus 1. So then we think absolute value positive 1. What's the absolute value of positive 1? How many steps away from 0 is 1? 1. So when in doubt, for our absolute values, think steps from 0. how far is it from 0? The distance from 0. All of those things being absolute value. So now we have 2 times 1 and then minus 1. Wait, we had that one before. We've seen 2 times 1 minus 1. What did we get as our answer on that? What is 2 times 1 minus 1? 1. Ooh, what are we noticing in our pattern? I have matchy pieces, which means I should also have matchy pieces. So what's going to go here? 3. Because we know these two match. So then, since I counted by the same amount, these guys match. As long as I count by like 1s here, or if I counted everybody by 2s and everybody by 2s, as long as I count by the same thing here as I did here, we can do that. We don't have to fill in that last piece. I do recommend doing at least 1 on either side of our vertex, just because that lets us double check that we got the right vertex. If we do not get a V-shaped graph where these 2 pieces match back up, we are not at the right spot. Or we had a problem with our absolute value. So this gives us our points to plot. We've got our -5, +3. We've got our -4, +1. I've got -3, -1. There's my vertex. Then we've got our -2, +1. And our -1, +3. So our graph here, we're going to use our rulers to connect them up. It should look like this. And we're going to have arrows on either end because this continues on forever. I could pick bigger x's. I could pick smaller x's. Okay, if you want to fill in absolutely for every single point, you can do as many as you want. You are absolutely welcome to. Once we start to notice these matching pieces, we are going to start to use those to help give us some, oh gosh, I don't have to do more of these calculations. So our last thing I'm going to ask you for today, is how is this one different from our parent function? So how is this different from the one we had on page 8? I'm going to sketch it up here for us again, just so we can look at it. Just give me a second, because I got to switch everything up to the light gray. So our parent function, the one we did on page 8, looks like this. How is this blue one different? It's got moved to the left, absolutely. What else? This got moved left. 1, 2, 3 spaces. What else is different? It went down 1. Yep. Anything else? It's skinnier, right? So this whole graph, it's like I went squished it. That is one of the jobs that we're going to be looking at on Monday for our A, H, and K numbers. So we're going to use these graphs to kind of look at these pieces. We're going to fill in the table down below it talking about our A, our H, and our K and what they do, and start identifying what those pieces are. I'm just not going to start that right now because we're going to talk it on Monday. So I'm going to give you guys homework 6. I have it. The front side of it is actually what we're going to talk about on Monday because organization is fun. So you guys can do like the review stuff at the bottom, and you might remember some of these things because I think we talked about them in Algebra 1. But other than that, not so much. But there are 2 absolute value graphs down here that you can graph just like the ones we just did. So on the back side, we have 2 absolute value graphs. And then this stuff is going to be what we talk about on Monday. It's not going to take super long to do, so like we'll be okay time-wise on it. So so this is definitely not due on Monday because we're talking about it on Monday. So Tuesday, I will fix that. So this we do a Tuesday, and I updated it on the wall over there. It's not on the screen. But this is the last homework of the chapter. Last one. Okay, so after this, it'll be the review, and then we have our quiz next Wednesday. So, we're getting to the end of this first chapter. So we have almost 10 minutes left. Announcements tomorrow will happen in about 6. So, take a look at this, work through some stuff. Do not forget about the Canvas assignments that are up every single week. Your Canvas assignment up. They auto-grade if you need more attempts on them because you want to have a different score, try things again. Let me know. I can always adjust things. If you have questions on those, let me know too. All that jazz. Make sure you turn in your bell work pages. Those will actually start going in today. Just because I put all the bell works in at one time in the one chapter, so I have all your other bell work pages here. So turn in the bell work pages because I will start getting those put in today for the whole chapter. They just go in one time, and I didn't want you all to keep track of 3 weeks worth of pages. That's why I keep track of them for you. Okay, so get your stuff turned in. Let me know if you have questions. All that jazz. Switch this. Way bigger. So 1/6 is going to be due on Tuesday. That is the last homework of this chapter. And then that quiz is on Wednesday. I'll have the review for you guys on Monday.